back to the Comark TV channel on YouTube. This is part 2 of our interview with former President and CEO Dick Fiore. 2022 marks the 50th anniversary for Comark in the broadcast industry. We hope you enjoy this interview. So Dick, where did Comark deploy our first UHF analog TV transmitter?
But the first transmitter system we ever sold was in Tampa Springs, Florida, our Clearwater marketplace. And that was channel 22 WCLF. Religious broadcaster, very nice gentleman, Bob DeAndre, as I remember. I do recall seeing him several times over the course of the last 40, 45 years, coming into the NAB booth and coming over and saying hello to my father. And it was always a good relationship. In fact, we just recently sold another transmitter system to WCLF.
How did the analog to DTV conversion affect Comark?
There was a book called Defining Vision. You know, it's sort of written after the analog to digital rollout got started. Engineers, NAB, were concerned about cellular communications. And they had a fear that they were going to have to give up spectrum, so they decided they wanted to go into a digital format. And it was time because DVB had, I think, started up over in Europe. It was more in the processing part of it than in the actual transmission. And everybody knew that there was going to be a DVB being digital video, anagrams that came out of this particular industry. But the analog to digital relationship is everybody in broadcasting believed that digital television had to happen. And there was a feeling that it would be more robust, more efficient, and better able to serve the industry moving forward to keep it worthwhile, to protect the frequency band that it was using. Because television stations were only licensed in the United States in order to serve the public interest. And that was the whole premise of going out and doing an ascertainment survey in the marketplace that you wanted to build a television station. Pretty comprehensive program that you had to put all together and formulate a lot of your programming to penetrate, understand, and try to help solve the issues within that particular DMA. So it's easy for the FCC to just say, hey, it was a temporary license, we're taking it away because you no longer need to be serving that, something else is going to be serving it. And I think that's really had a lot to do with it. But it was difficult for television stations to once they had asked for it, to control how it was going to be implemented. And when the FCC came in and said, all right, you want digital television, we'll give you digital television, here you go. Everybody gets a second license. You have to build a brand new transmitter system, a new antenna system, new power plant, and you have to broadcast both for, I think they said at the time, 6 years, something like that. It was a number that they picked and they thought it could be done, but there's no way it was going to get done. It was a huge boon to the broadcast industry, but it was a huge cost for equipment suppliers, but it's a huge cost for television stations because it requires now more engineering staff, more space on the tower. Typically they didn't own their own towers, they would lease tower space for the antenna transmission line, a new transmitter plant which would of course consume electricity, and the increase in advertising revenue was zero to begin with. And nobody was watching digital television when everybody started putting digital TV stations on. But it was interesting. It was an engineering challenge, and everybody knew it was the future of broadcasting. But it was also driven by what we were going to do. Who was going to make decisions relative to the marketplace? And a couple of groups sprang up. One was ATSC, American Television Standards Committee. And we got involved in designing or helping to design a new modulation scheme for digital broadcasting. One of the features that ATSC wanted to do was to implement a full digital broadcast scheme. So they went out and they asked for applications by different manufacturers to make a proposal for what they would do. And I believe there were 6 or 7 different proponent systems, some of which had some very interesting parts, but nothing that seemed to really stick out. And in the end, ATSC asked 4 or 5 companies to see whether or not they were interested in forming what they considered called the Grand Alliance. And the Grand Alliance included, at that time, Zenith, which is now LG. Zenith Electrical, Zenith is part of LG, it was swallowed up by LG. Zenith, Thomson, Sarnoff Labs, Adobe, but we were Thomson, and we were intimately involved in it. I remember working with all of these people to develop the first over-the-air live broadcast of digital television using this new standard, which we called ATSC. It was fundamentally based upon 8VSB, and we went with 8VSB because it was more efficient in a 6-band megahertz bandwidth than COFDM. It was not as robust, but I think the efficiency and the fact that they believed that it could operate well in this domain was something that they wanted to do. And I think there were also issues relative to, if I'm not mistaken, copyrights. So 8VSB was selected. It was designed, we used that as the standard for the exciters. And the first exciter and transmitter system that put on the air was done by the American Testing Labs down in Washington, D.C., WRC. It used one of our amplifiers. It used the Grand Alliance modulator. I remember walking into the room where the modulator was, and the modulator room was racks and racks and racks of equipment and wires hanging all over the place. Well, now, of course, it's all changed because we've gone to ATSC3, and it was an interesting time to be involved in the broadcasting. And I remember going to see the first live presentation, and they had, the thing that I was amazed about with her, there was a news anchor, and he was broadcasting, and it was 2 receivers. One was analog, one was digital. But the delay for the digital was much greater than the analog. And the guy would broadcast, and you'd hear the voice and then the voice again. And he didn't miss a beat broadcasting any of the words. And I found that to be really intriguing because here was a guy who was talking and yet hearing himself in 2 different echoes seconds later and still continued talking. I guess maybe because he had something to read in front of him and it was easier for him to concentrate on that. But that impressed me how he could do that in the presentation. So that's how we got involved in digital broadcasting. But listen, every single television station in the United States, high power, had to go digital within a specific period of time as defined by the FCC, and had everything to do with the markets. And in order to drive the markets, the top 10 markets, the 4 major broadcasters and all, ABC, CBS, NBC, and Fox, had to go on the air first at full power, and so on, until you got to the marketplace where the markets just could not afford to build out a $2 or $3 million infrastructure and be spending $500,000, $600,000 a year to support that, and not have any additional revenues coming in. It would have killed a lot of broadcasters. So you saw a lot of consolidation go on. You saw a lot of, and then the FCC finally said, well, we understand. So we're going to let you put on the air low powers. Well, there's a lot of changes relative to what your strategies were then. So it was a constant design of transmitter systems to meet the customer's requirements. And I think we did very well in coming up with a number of different solutions to meet all their requirements. But specifically, we'll get back to why I think we were in a great position relative to the analog to digital world. And that was because we built an IoT transmitter system. And IoTs operated common amplification, which is exactly what digital wanted. And our competition were, at the time, still building Klystron-based transmitter systems, and they weren't capable of doing broadband and anywhere near the efficiencies that we were doing. And therefore, we got a lot of competition in the industry quickly, and we fought off most of it. So out of the Grand Alliance, we had to reduce this room full of electrical wiring down into smaller devices. And Zenith went off, and everybody in the Grand Alliance was going to be allowed to build an exciter. And Zenith went off, built their own exciter, and eventually sold it to transmitter companies. Well, we decided we would design our own. One of the things that we came up with in our design was called MODAP. The key for what we did was we developed digital adaptive pre-correction, not just on the linear side, but also on the nonlinear. And basically, that just made life so much easier for engineers to just click a button and have the system correct it for itself. And we were the only one who designed it. We were the only ones who had it. So again, another one of those technical initiatives that we undertook because we thought that this would be a great idea for broadcasters and, of course, ourselves. And again, it won. It made it easier for us to talk to broadcasters that we were never going to be able to talk to without coming up with great ideas.
We hope you enjoyed this interview with Dick Fiore. Please like, share, and subscribe for future videos, and thank Comark and CDS for all things digital TV, MPEG test, and encoding related. Thanks for watching.